In this video, we're going to find absolute extrema. It says find the absolute maximum and absolute minimum of the function f of x equals x over x squared plus 1 over the interval -5 to 3. So we're bounded at -5 and 3. Let's plug in those endpoints and see how high those two pieces would be. Because the endpoints can be absolute extrema. So we're going to test those first, and we'll find the critical points to test to see how high those are on the graph. So we're looking for the y values here. -5, I put it into the function for f of x. I get -5 squared plus 1 on the bottom there. Do the same thing with the 3. So 3 over 3 squared plus 1. When I plug those in, I get -5 over 26. And then this would be 3 over, let's see, 9, 10, 3/10. So you can see that -5 over 26 is smaller than 3/10. We want to find the critical points now of this rational function. So to do that, we're going to take the derivative of it. So we're going to say f prime of x is equal to, and I'm going to do the quotient rule there. So that's u equals x, u prime is 1, v would be x squared plus 1, and v prime is going to be 2x. I take the derivative there. So I use u prime times v, so that's x squared plus 1, minus, so I'm taking u prime times v, now minus u times v prime, so that'd be 2x squared. And that's all divided by x squared plus 1 squared, v squared on the bottom. Now I'm going to set this equal to 0. So I got 0 equals, this would be -x squared plus 1 on top over x squared plus 1 squared. Now I'm going to multiply each side by the denominator here. So I'm just going to write MBD, multiply by denominator. If I multiply this side by the denominator, it cancels. If I multiply this side by the denominator, 0 cancels it out. So I end up with 0 equals -x squared plus 1. We're going to subtract the 1 over, so I get -1 equals -x squared. I'm going to drop both negative signs, so I have 1 equals x squared. So I divide it by -1. And then I take the square root on each side, and I get plus and minus 1 equals x. So those are my critical points. I'm going to write those here. And now I'm going to test those critical points. So I'm going to come up here and I'm going to say, all right, what's f of 1? And then what's f of -1? So f of 1, if I plug it in, I end up with 1 over 1 squared plus 1. If I do the same thing with -1, I get -1 over -1 squared plus 1. So this would be 1 over 2, and this would be -1 over 2. So now I'm going to order these from lowest to highest. So the smallest value is this -1/2. I'm going to say -1/2. Comma, and then the next smallest would be -5 over 26. And then we've got 3/10, and then we've got 1/2. So our absolute min is going to be that value, and our absolute max is going to be that value. So this is absolute max, and this is the absolute min. Because those y values are we got the smallest and the largest. Now, what we want to do is we want to write this as a coordinate. So how did I get the -1/2? Well, the absolute min is actually -1 comma, negative 1/2. And the absolute max would actually be 1 comma 1/2. X value describing where it's at. And those are our two solutions.